Hello, my name is Thomas Kim. Today is February 23rd, 2017. My name is Thomas Kim. Through next few videos, we will try to implement function using flex and lex. Before we do that, we want to make Reentrant parser and lex. We want to understand the concept Reentrant parser and lex, how to implement it. To follow my video, you need to have sample source code, and also you need tools. So please visit this website in the web browser like this. Then go to C++ coding. Bison and Flex. Select this menu, Bison and Flex. Scroll down here. Reentrant parser and lex. Download sample source. It's not actual sample. It has tools in it. We will use it. And Google Chrome falsely alarms that my file is dangerous, but it is not. So select keep, and this web page provides MD5 code to check integrity of my file. When it is downloaded, click show folder, and this file would be downloaded. Using MD5, you can check integrity of my file. This is the folder I just downloaded. Click it, then copy the MD5 code, match it. From this website, you can have MD5 code. Match it means this is the file I uploaded. Exit. And using this file, it will be downloaded here. Right click, then extract here. Then you can copy and paste this whole file. Copy and move to yylex this folder. If you do not have this folder in C drive, break it. Then name it yylex. Name it exactly as it is. Then copy here. It has three folders here. Collect resource. Then copy Reentrant Bison and Flex source solution. Copy and paste it to your working folder like yylex. For example, this D drive to your project working folder, and paste, copy paste. I already did like this. This is actually the code I uploaded, so already did. If you haven't done that, please do it. Then go back to your system folder, C drive, yylex, this folder. Then select Win Flex by this folder. No, not this one. This WinFlex Bison. It has window Bison and Flex code. Copy it. Select the folder. Right click it. System. Advanced settings here. Environment variable. If you do not have this path variable, you can select path variable here. They are the same anyway. This a little bit different, but actually works. Effect is the same. In my case, I select path here. At the end, semicolon, paste. Okay, click OK. Then OK again, and close it. No, we will open it. Let it open. I will close it. Then test the tools. Here, command prompt. We will test WinFlex version. It should be 2.6.3 and Win Bison version. Win Bison version. Yeah, I need two minus. Then it should be 3.0.4. So we are using latest version as of today. And if you are using Bison of Insigwin, you should have the same thing. excuse me. If you haven't installed the Cygwin Bison version and Bison included in Cygwin package, please watch my previous video and install it. Or if you are just using WinBison and WinFlex, you don't need to install because I already included in the package. Right? Now exit. We will run Visual Studio for the first time, for example, and open the Reentrant Bison Flex solution you copied. For example, I need to change my default settings here. Document. Or please select in document, in environment document, please select this one. And also in general, I will change my working folder to dbsoft here. And in your case, you can select your folder, working folder. Then here it is. At build and run, please select this to normal. If it is not normal, default is minimum, or you can select the detail or whatever. But don't, default is minimal, but please select normal. Okay, click OK. Then and we will open open project we copied. Then select the folder Reentrant Bison Flex version. This is here. As I told you before, if you if you go to the resource folder that we downloaded, this is the file. You can copy to your working folder. In my case, I already did, and it's here. This. This is the code I created a few minutes ago before I record. Before I tape this video, I just created it, and I will show you how to create. Before I explain about this code, I will let you know about code snippet or something like that. That's very handy later. I will try to rebuild or rebuild. Then I will keep explaining. Okay, it succeeds. Let me check one property option, just in case. Currently, it is set WinFlex, WinCap. If you are using Cygwin Bison, you have to fix like this. You have to remove this, and you also have to remove this like this. Okay, but in my case, then you have to fix like this if you are using Flex included in Cygwin. Okay. Also, if you are using Flex Bison included in Cygwin, then you also have to remove this one like this. Okay, I will double check it. This setting is for Flex in Cygwin. This setting is Flex in Bison in Cygwin. So I will compile them, rebuild them again. Okay, even after I changed the compiler, Bison and Flex version, it is still working. So before we further go, right, I will explain very handy things, very useful things for our future video. Go to file menu, then export template. We are creating template. item template. Next, and select lexa first. Next, and you have to template name exactly lexa, just lexa. Okay. Then here put some description. Reentrant lexical scanner, like this. Okay, if you don't need the image, but if you have image, it would be convenient. For example, browse and go to the download folder. You just downloaded my file dbsoft. You download it here. Custom, you have to download here. Resource icon. Then we are making settings. Flex icon. Click this. Then finish. Okay, then it's done. If you have this folder, remember that it's in your document Visual Studio 2015 my exported template. You can remove it if you don't want it, but just keep it there. And go to file menu again, export template, item template. Next, then select parser, this file. Next, and next once again, here type parser like this exactly, and description is Reentrant syntax analyzer, syntax parser. I will like this, and icon will be select the same way here. And here, resource icon. This is the file you downloaded, like this. Okay, finish. Then one other zip file is created. We will make two other things. We need to go to file again, export template, item template, and now we are selecting one header file, parser cpp, this one. Next, here we have to name exactly the same, like this, exactly the same. Here, parse tree. Then here, reentrant parser tree implementation, like this. Okay, it doesn't have icons, so just click finish. You have to name exactly the same like this at this part because it is used as file and finish. Okay, it is created. Now another one, finally. And you have to find header file, parser tree, right click, not right click, go file menu, and export template, item, here, parser tree, like this. Next, here exactly the same, like parser, parse tree, exactly the same, here, reentrant parser tree header file, like this. Okay, finish. Already exists. No, I will change it, like delete it. I will change it, just underscore delete it. After this we will delete it. Okay, finish. Okay, it is made because it conflicts, so click OK. So we made, and we make another one. Lastly, template, item, next, and reentrant. Reentrant CPP here. Next, Reentrant APP. This is okay. Here, Reentrant main, Reentrant main. I will name it like this. We don't have icon, just finish. Okay, now let's close it. Close it. Close it. Close solution. Okay, we just made template. Now we have to close and start again. So we are creating a new Bison Flex solution for Reentrant parser and lexical scanner, and then we will implement more advanced features like function, goto, etc. All features needed in the fully implemented scripting language. Okay, go to file new project. We are creating absolutely new project. Okay, before I do that, I will make some delete. In my case, here in my DB software tutorial, I want to delete this file, all the files as well. Delete. Okay, then I will create not this one. Okay, so okay. Here we will select all default, just cancel application, just finish. We created a simple cancel application, and then we don't need it. Close it. I will remove it. Delete, remove, and select delete. We don't need it. Then add one source file, select here, right click, add new item. Voila! Reentrant app here, select zipper. This is the one we added. Add. Okay, it is added. It is template code. Then, okay, I will make a filter here. Right click, project. Right click, I will create two new filters. Bison, Flex, files, and one more. Here, generated files. Then right click, generate the file. New filter, header. Files, then generate the file again, right click, new filter, source files, like inside the generated file. Okay, if you made wrong, then you can rename like this. Okay, right click and rename, or even you can delete. Okay, anyway, say right click, Bison Flex files, right click, add new item. You have to see this, right? You have to see, because we added this as template, add. Then Bison template file is added to your project. Then right click and add new. We are adding Flex template file, add. Okay. Then we are adding two template files. It's your own new application. Then we have to make it settings. Right click, properties. Then click here. Make sure it's all configuration, all platform. Make sure. Then select this. Go to custom build tool. Apply. And some people say there are much easier way. You don't need to make settings every time. Okay, I know. Actually, I know. There is much easier way. But I'm doing this because of compatibility. Compatibility with other tools. Okay? I know. Much easier way. But I'm doing this on purpose. Custom. Then general here. if you have you just downloaded and installed my you just downloaded this really this you just downloaded this and have settings like this. This Win Bison and Flex is already included, so I will default Win Flex. Note that this is Lexus file, Lexus property setting. Then in case of WinFlex, you should not forget WinCompat. Okay, WinCompat. You should not forget. Then percent identity like this. That's it. That's it. Okay. Then you can change it like generating lexical scanner. Okay, lexical scanner, lexical analyzer, whatever. It doesn't matter. Then percent file name cpp. Then put a colon. Okay, put a colon. Then file name h. Then click apply. Okay. Then select parser. You have to click apply after changing. Select the parser. Okay. Then it should be parser HTML. Then you should select custom build tool. Okay. Apply. Then custom build tool general here. Then right click. Here we are using Win Bison like this. It's very simple identity like this identity. Okay, then click OK. Here you are changing generating syntax parser like this. Output will be the same like file name cpp, then file name .h like this. Apply. Okay. Say then ready. You are ready. Then it has all stopcode here. So whenever next time when you do, all you need is just following this. You don't need to make all settings here again and then again, etc. Now we will compile it with Lexa first. Compile it. We have to compile. You have to compile first. Okay, it is compiled successfully. And right click Lex parser and then compile it. Compiled. Then select generated file header. Right click, add existing. Then it will open. We will select two header file. Click Control. Then two files like this. Two files added. Source files. Add existing. Parser CPP. Then Lexa CPP. You are adding two CPP files like this. Now build and compile. Hurrah! Control F5. It doesn't work. Okay, I will show you why. No, what's the problem? It doesn't work. Click OK. Okay, let's see. You should have blah 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 parser tree no such file directory because we changed the name. Oh, we have to add two files. Sorry, I forgot it. Then source file, right click, we have to add new file, new item like this, new item. Then this is source file, then source file parse tree implementation. Okay, parse tree. Then click OK. Then parse tree CPP is added. We need one header file, not here, here. Right click here, not here. Okay, not here, but here. Here, right click, add new item. Then this parser tree delete. Okay? I think I should have named not delete like this. Delete this like this. Okay, then add. Okay, then add it. Okay, then let's compile again. Control F5 for compiling to compile and build. Hey, we have error message again. Say, what is most important is this. You unexpected end up looking precompiled header. Say you have to disable precompiled header here. Right click, properties, go to C++, precompiled header, not using. Okay, only two files, not using. Apply. Then parser CPP, not using. Okay, apply. Then we still have another error message. Okay, now click Ctrl F5 again. Then what's our next error message? Oh, it's working now. Okay, it's working. DE debug on. It's in debugging mode. Okay. Okay. Debug DE debug OFF. Okay, its debugging mode is off. This way you can change. You can create a new solution. New reentrant parser. This is reentrant parser actually, and this way you can create a new project very easily. I will detail all the dark code about this. Okay, take in your case and one thing more. Just one thing more. If you are, for example, if you are using Bison and Flex included in Sigwin, then you have to change. You may use like a file name like this. Then you have to remove it. You have to do like this. Okay. You can change like settings. Also parser. If you are using Bison in Sigwin, then name just like this. Then it should be working. Okay. Now rebuild. Okay, it's working successfully. It is the entrant parser. It's very complicated. Okay, the default file. I will show you default code. This is minimum code actually. Okay, this is minimum code. These are minimum code to make reentrant parser. It's minimum, but we will use it. Once we create it, then we will use it again and again. We will never create it again. Okay, so you have to understand what's this, what's that, what's this, what's that. If in you, so I will detail a few minutes later after a copy. We will take a copy break here. After a few minutes, you stop the video and take a coffee, take a deep breath. It's very complicated. Okay? It's coffee time. 5-10 minutes after. Pause the video and take a deep breath. See you soon. After a few minutes, 5 minutes, 10 minutes. Hi, I am back. And I would like to warn you in advance, this is quite a lot complicated. So please take a deep breath, and for first session, when you are watching this video for the first time, then just try to understand the concept. I will detail everything, so it's pretty much complicated. Don't worry, you don't do this next time. Once you understand and you create the template as I did, you already did using my code. You don't need to do the same thing again and again. So, but for the first time, you need to understand. Okay, so I will move it to another window. Then I will start another instance of Visual Studio. Here, we make a new project for the first time. your project. In console application, you can use default, but I will just change it. Console Reentrant solution. You can name it anything. I will just have console application like this. Just click OK. Then we select default. We can select default. Finish. Reentrant parse is really cool, and we will use this technique to implement the full-featured scripting language. It will support functions, if then else, and whatever all advanced features of programming scripting language we will implement in next my video series in this channel. Okay, so at this stage we don't need it. I will right click and delete. We can use it. Okay, we can use it anyway, and we will add filter here. This is not compulsory, but it would be better choice. Bison, Flex, files like this. Then right click, add new. We can next time when you do, you can add this select and select this, but we will start a blank. Okay, I will change it to something else. Instead of Lexa, I will say scanner. Just a scanner. Okay, it will add extension L, I guess, like this, scanner. Okay, this is template code. See, we made previously. I will click it. I will then remove them. Okay, I selected, deleted all to explain everything from scratch. Then right click, add again, new. Now parser. I will say analyzer. Why? Or I will just say analyzer. Why extension will be created like analyzer. I will also delete all. I will explain them every minute details like this. Then I will create one more filter. Generated files. Then right click, add new item, new filter. Here header files inside, and another one here new filter, source files. I think it should be changed something. Okay, it's okay. Then at this point we will create a class. We will create the class. Watch carefully. Right click. You can do like in class view. You can right click, add class. You can do like this. Also in solution view, right click, click project, right click, add, then class. Actually these two are the same. Okay, then add. Here it will be C. I will name it anything, just more descriptive name. Parser. No. I will name it scanner. Parser. CLS. I will name it like this. Okay, scanner parser CLS. You can name it anything, but I will just name it this way. C scanner parser CLS. These are the source files. Click finish. Okay, save all. Save all. Then we will start with lexical analyze. Okay, we will use two of them simultaneously. Lexical analyzer should start with quite a lot of options. Before we do that, we will make a compiler setting, generate right-click analyzer, properties, and make sure all configuration, participate, and custom tools, apply, then custom build tool, general, here, edit, it will be win Bison, no, this should be Bison file, lexical and .y is Bison file, percent identity, like this. If you don't understand what is identity, then click macro and scroll down and you can find what is identity. Identity is the analyzer.y, okay? Click OK here. Now we will change it because we have to change it to understand the message. Generating syntax parser like this. Output, this is important, percent, then file name, cpp, semicolon, percent, file name, h. Okay, you should enter like this, apply, click OK. Let me check once again. Click OK, then lex. Okay, this is correct. If you are using Bison included in Cygwin, then you have to remove like this. Okay, we are using Win Bison. Anyway, click OK. Right click, properties here, select, scroll down, custom build tool, apply, then custom general here. I will edit like this. Win Flex 2 minus win compat like this, percent identity like this, then click OK. Here we'll change it, generating lexical scanner, then output will be the same, like percent file name, cpp, percent file name .h. Okay, then click apply. Okay, at this point setting is done. Now we will flash out the code. Okay, so the first thing we need to do in parser analyzer is lexical syntax parser is we have to generate defines. This is not define. This is not define. Okay, this is defines, and this is not defines, not sharp. This is wrong. Okay, this is wrong. You have to use percent defines. Okay, also it should be the first column. You can put it the second row or third row, but it should be the first column. That's preferred. Then you can put file names like exactly the same. You can put anything but put the same thing. Okay, like analyzer dot h, like header file is creating. Okay, I will put a message here. Generating header, I see, parser header file like this. Okay, then put a blank space when you give your comment like this. Then we will create source files, implementation file defines like analyzer cpp. This is called implementation file. It will be generating parser implementation file. Okay, because if you don't, because we named like a lexical analyzer.y, we named the same way and only change the extensions. If we give them, we don't need to use alpha file command line switch. Okay. Sorry, I made a mistake. This is not defined. This is output. Sorry, like this. Not defined. The first one should be it. This is defines header file, output implementation file. You should be careful. It's confusing actually. So once we do, we don't need to do this again. So the next thing is for location tracking. Location tracking means like the 9 number in source code when we give error message to our user of our software that we developed, our own language. We sometimes need to give more specific error message at what line the error occurs. In such case, we can implement the custom location, but we can use Bison's provided location tracking method. Then we will use debug message. Debug message means this is for Bison debug message for us, the developer. I mean we, the programmer. It gives detailed error messages or warning messages while building Bison file to generating scanner or something like that. Then we will also enable, this is not compulsory, but it's much better when we program in the long run. And I will add one more. This is define parse tree. It is not compulsory, but not necessarily necessary, but it would be much more helpful when you do debugging our language. Our Bison generated file enable runtime trace. It will be very useful, this feature. And another thing, I will define API pure full. This command, this instructs Bison to generate reentrant parser. Okay, so this line is very important if we are going to create reentrant parser. Reentrant parser is thread safe if you code properly. Okay, so the next thing is, this is define API API prefix. This is useful actually, like TK. This option is used when we make multiple parsers in the same project. So it changes. You can name it anything. Bison and Flex default by default they use like a yylex, like that. Then we can change it to something else like TK, Thomas King, like this. Or if your name is Jane Demi Moore, then DM, like this. Okay, then TK. But we will not use this feature today. But I added it for future expansion. Okay. Then another option is okay, syntax error. This is define once again, define. This is parse error purpose. Parse error purpose. This is not for us. This is for our users. I mean, if somebody else uses my own software, my programming language, then this feature will be useful to give them detailed message. Okay, provides verbose error messages about syntax error. Okay, then next is let me see if I missed anything. This part is really important. PALAM, then scan T scanner. This part, this is additional argument or parameter. Function call argument, call argument or parameter. Argument, it's actually argument and also becomes parameter. Call argument for lex, reentrant lex. It's very important. I will explain. I will give more explains. I will give more explanations about it. So I will disable it to give you error messages. Okay. Then I will enable it. Why it is important. Then another thing is for parser. Okay. Define parse. This is parse. Parse PARAM. PARAM means parameter. Then C. What's the name of our class we added? Let's see. Class view. C scanner parser CLS. Wow, very difficult name. C scanner parser CLS and the pointer. It should be pointer. Then P scanner parser. It can be anything, but it should be, this parameter should be the class we created. If you don't remember, please wind back and watch why I create. You see, we created it. This is custom class. It will be sent over to yyparse. About that you will see very soon. I also disable it. Additional custom parameter to yyparse. I will be back here again and give detailed explanation about it. So I will disable for the time. Okay, I will disable like this. Then let's go back. let's keep continue. Then okay, in older days they used code block like this. This is still useful, but we will not use this. We will change it. The Flex at Bison has upgraded like code requires, and like this. It's wrong. It will give you error message, and I will give you reasons. It will give you error message. I will correct it later because it's very important. This error message is important in some case. Then here we can put, you can also do this, like change like this, but it's not recommended because of Flex syntax. In Flex syntax, I will go to Flex syntax lexical scanner here. I will also do something like that to compare. Okay, say here, and I have come to lexer because these two should work together. Say in lexer, say, do you remember the first thing we is generate lexical parser header files? We will the same way we have to give option to create out file. This is out file. The switch is very confusing, right? This is, this is output, this is out file. Really confusing, I guess. You should take it because these tools are developed two different person, absolutely different two organization. They developed independently, so they named their options as they want. So this should be output. This should be in analyzer. It should be output. So output file will be lexer cpp. No, not lexer. Let's make it the same name like this. It should be scanner cpp. I will use scanner cpp. Scanner. You can name it anything, but try to follow exactly the same like this. It's easier to remember. Then I will add a message. If you want to comment, don't do this. Don't put comment at the first line. Give a blank space. Then here, output lexical, I would say lexical scanner implementation file. Then I will put header file. Okay, I can say option header file. Once again, scanner h like this. It's very ugly, right? And I will just let it do it. It's ugly, but okay. Then you should not do like this. Okay, the first line you should not put comment at the first column. This is first column. You have to put space like this. Otherwise, you will give error message. I will tell you that again. Lexical scanner header file. Then the next is once again option. Then 8-bit scanner. We will use 8-bit scanner. It is actually default, but I will just use it. Reentrant. This is the core reentrant scanner we are making. No YY WAP. No WAP wrap. No YY wrap. Reentrant scanner. Okay. So the next is we are going to use the stack. We will use include. Say when we make our own language, we want to include some other files. I mean, we want to enable our users to include our external header files or something, then to use that, to use include feature, to implement, I will say, to implement include feature in our language, it will be useful. So this option is option stack. Okay, option stack. I will in future, maybe I will have time to explain about this feature, how to make include, how to implement include feature. Then option and one no default, no default. Okay, just use it. It's useful. Then another is, this is very important option, Bison bridge. You understand? Bridge, B-R-I-D-G-E, bridge. Bison bridge. Then Bison locations. These two are useful. You can do this option. You can do in two separate lines, but I will just put them in a single line. Oh, I will disable it for the time being. I will give you more explanations about it. For interface with Bison. Asks Bison. No, I will just say it. I will be back here again, like this. Then it can be also useful. Okay, option line and no number. See, let's scanner, I mean lexer scanner handle update line number of user code. User means our user, the user who are using our software. The user code scanning. It's useful. Someday I may have chance to explain about this. Next option will be the same way we can say option. Say we are using single lexical analyzer, single scanner, but sometimes we need more than one lexical analyzer and more than one scanner. In such case, if we use default YY prefix, then it can cause problems. So in case of Flex, we can use YY what's the prefix and YY prefix like this and like TK like this. Okay, in case of Bison, this is Bison, right? We use the same thing like this. The syntax is define API prefix TK. In case of Bison, we have to say option prefix TK. These are actually the same thing. This is for Bison. This is for Flex. This is for Bison. But Bison sets options using define %define. Flex sets options option method. We have to take it. Okay, I will disable for a minute in this session, and sometime in future maybe I have more chance to talk about it. Then another thing is okay, we need extra I will give you some messages. When we use multiple scanner in a project, then we need to change YY to something else. This option does that. Okay. Then we need to we want to toss our class. Once again, class view. This is the option we are going to set. This option is important. Then this is option and extra minus, not underscore, minus and type equal. Then we should give this name. Okay, this name is pointer. CSC scanner parser CLS, then pointer. Okay, this is pointer. Our own I say scanner parser driver class. You may understand later. Say, do you remember you have seen this before? Yes, when we set Bison, for example, where we have set here, we have set these options. This option, we have seen it before. In case of Bison, you have to set this. In case of Flex, you have to set this. I will talk about it more, a few minutes later. In this session, at the later part of this session, I will talk about it more. So I will disable it, but it is very important to understand and to use it. I will be back. I will explain in detail, in very detail. If you set this, you have to set this too. Then next, I will be put the generated value. Now we will use, in the older days they used like this in the prologue section. This is usually called the prologue section, but we don't do this again now. We can still use, but it's much better. Okay, top. Okay, it's wrong, so I will tell you why it's wrong. Okay, it is also wrong. If you put space, it's wrong. It's very hard to find debug. Okay, so I will say here, it will give error messages. Then I will put pragma. It puts code at the top of generated scanner implementation part. Pragma warning, disable 4005. This is not important, but this is useful handy. Then we put as include IO stream like this, include IO stream. Then include, we need CMath mathematics. Then include, we may need string, C string class, and also we may need string class. This is C++. And using namespace std. Actually, I don't like this, but I usually give a full namespace in my code, but I will use this for the time being. Then we include this, implement this part. We have to include this one. Okay, then here include lex analyzer .h. We include this, and that's it. That's it here. This part is called declaration or definition section. Then comes rule section. This is rule. This marks rule section. This is wrong. It should be first column like this. Then this definition we will name. I said the name. I will name int integer. This is integer. Then give regular expression definition. 0 is like a number. It means one digit from 0 to 9, just single digit. Okay, so plus means one or more. So we will talk about it later. Then I will add another one, character A to Z, A to Z, like no sorry, A to Z, one or more also. This is called the name. This is definition. Name, definition. We are in definition section. Here I will name ntz. This is rule, and this is called action. She called action. This is rule. This is action. I will just name it. Before we doing this, I will go back to scanner. Is almost done. I will go back to parser here. I will keep going parser. Actually, when you program, you always do simultaneous. Once picks it here, and then picks it here. One picks it here, picks it here, something like that. Then requires goes top of the parser implementation file. Here, I will do the same. Include and IO string and some other thing. Include C Studio probably. stdio and include. Okay, it's enough. Then include. We will include this one. We will include this one. Which one? Here. Scanner parser class. Here. Scanner parser class .h. Okay. Then we need type def. Type def like this. This is void pointer. YY scan t. This file is actually defines. It actually defines. It is plug scanner's data type. Okay. This is scanner Plexus scan data type. Data type. We have to include it, or otherwise it causes trouble. For example, to like this. It causes trouble later. I will explain why. Then now we are using code section. This is important. Like this. No. Code. This is code require. This is code. This is just code. Like this. Like this. Okay. And here we'll put some type 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 def void yy scan t. Hey, it is useless, right? We are doing the same thing. We don't need this. I will remove it. And it should not be %, okay? It should not be % like this. It should be like this, okay? Otherwise, it will give error messages. So it should not be %. You should remove % here, like this. Then I will keep going. Scan until. I will name it Flex data type. I mean, this data type is defined by the flex. This data type is defined by flex. But it is defined this way anyway. Another thing is code require extern int yylex. No, it's wrong. We will fix it. It is wrong. We will fix it. I will explain why it is wrong. Then we need error message extern void error. We have the constant character message. When we are using how can I say, simple parser, we can do this, but it is also wrong. It is also wrong. I will explain why. Then later I will explain it again. Then we need initial action like this. Initial action, %initial action. This code will be code in this block is executed each and every time yyparse is called. Here I will use yyDebug called before our grammar is executed. Okay. Then yyDebug is used for setting runtime, for runtime debugging, debugging. It's very handy. It's really handy, you know. I will explain it later. Okay. It's default. Then next we are going to use Bison data type. Okay, then that famous union comes here. Wow, what the heck is it? And it's the union statement. Or semantic data type comes here. Semantic data type. You should not do this, okay? Maybe, I'm not sure, but the manual says I should not add semicolon after this. Here, intg will be used as a tag, okay? Semantic data tag, and the int is type. It is called a type tag, okay? Then if we are going to use character pointer character, I will name it cstr, like C string, okay? It's really bad, but I will for demonstration purpose, okay? This is called semantic data type tag, okay? Then let's see here, and we are going to define here. It's very useful, I think. Define API. What's that? Token prefix. I think it's very useful. It can be tkn underscore. You should not do this. You should remove any blank space in the curly brace, okay? You should do this. I will talk about this later. It means our token names will be appended with tkn underscore, okay? Then what's next? and we are defining token token intz. Okay, this is token semantic data tag we defined here. We are defining here and say intz. Okay, then we can name it integer like this. This is for textual. The same thing. Integer integer. This quote string is used the same way. I will explain it later. Then token, we are using CSTR. CSTR is something new. This one, CSTR. We will name it. This is also token type, CSTR, and name it like a C string, like this. Then I will soon explain this token debug, DEBUG, debug on. We can define our arbitrarily of. If we define like this, it means it does not have a specific token and semantic value. You understand? This intz will have an integer semantic value because we defined int. C string will have a character string, but in case of this without tag, this is called tag. Semantic data type tag. This is token name. CSTR is called token name or token. This is called tokens semantic data type tag. Okay. Then this does not have specific semantic value. Okay, so go next. It's very boring, right? Yes, it is. We still have to go a lot, but it's a long journey. Now we define grouping. These are tokens are I will explain. Tokens are terminal symbol. Okay, terminal symbols are defined using token left, right, etc. Okay, so these two are tokens, intg, CSTR token, and these are token too. But we are now defining non-terminals. Non-terminal also needs tag type semantic tag, intg. This is non-terminal. Okay, non-terminal will be expr. I will explain it later. Okay, expr. I will give it 해서 terminal, non-terminal symbols should be defined using type Bison keyword. So anything you define with the type is non-terminal. Okay, anything you define with the type is non-terminal, and any other thing you define with the token or left, right, non-associate, precedence, etc., they are tokens. Okay, this is non-terminal. Non-terminal is also used as grouping in rule. So next thing is this can be useful. This is not necessary, but can be useful for parser debugging. Debugging means we are going when we fix and tracing. Yes. This would be printer. It's not hardware printer. It's printer means display, put message on the screen usually. Then curly like this. We can put anything, any C string, F print F like this. It can be YY output. This is, you can see this is the file name, right? YY put file name. Then string format like this. String format. Then put a $. Very ugly statement, right? Then semicolon. This is C code, okay? C code. Then what is $? Double dollar means semantic value. That comes after curly brace. Then comes CSTR. CSTR is type tag name, type tag, semantic type tag. This CSTR, and we defined here. Any type will be defined here when we do debugging. I will talk more about it later. Like this. Then you can also read about this on the Bison manual. Then we will use destructor. Destructor. Like this. Here we can std cout. We can do anything, but I will say $. This is semantic values. Semantic value. This code is deleted like this. These values can be used when the scanner unwinds stack. Delete. You can delete like $. Is semantic value. We are putting C code here. Then we put null ptr semicolon like this. Then what's this? I will say CSTR character type. We will declare these character type dynamically, so they should be deleted when stack unwinds. Okay. Next, start program. Our symbol for our designation of start of program. Then now grammar rule begins. Grammar section begins. This is grammar section. Here our program grammar rule. This typically very boilerplate. How can I say boilerplate? Program. Then empty. empty. It is actually recursive, and program line. And the last line should be semicolon. It actually means something like this. This is one grammar rule, one rule, or grouping, one rule, program. This is another grouping. What's this? Program line. We can do this actually, okay? But it should terminate with a semicolon like this. Understand? But we can put it into a single grouping using like what's this, vertical bar. Then we can make it into a single one like this, single grouping. Then the end it's okay, but it's clear to our eyes. Then next, what comes next? This symbol is not yet defined, so we define it. Line, colon. Then we can make simple ones like new line character, and another rule here, expr. Then we will put some semantic actions here, okay? std cout, and say parsed. We can put some $1. Its semantic value is $1. expr can have values, right? Semantic value that can be $1. Okay, this semantic value is $, like this, $. But it does not, we haven't defined the semantic value for line yet. We defined expl as expl. This is grouping actually. Non-terminal, it has intg. Intg means integer, okay? So this value is integer. Its semantic value is integer. Like this, okay? Clearly. Then another rule, cstr. This is a C string, right? C string. It's really complex. I told you in advance. It could be very boring, but at the end you will feel really happy. Okay. Say I will put code here. More code later. Then here once again, and I will put debug. Debug on. I will put like this. I will say debug 1. I will talk more about this later. Then debug off like this. Then debug 0 like this. Sorry, this should be single quote. We can do like this, okay? Here, turn on runtime debugging. Here, be careful. It should be, this is one rule, and its action should come at the same line. This is wrong, okay? Action should always come at the same line. This is the rule. And the next line can come anywhere, okay? Then I will make it end. End. I will make it into a single line. Sorry, it doesn't work. I have to do this, okay? Then turn off. This turns off. Turn off runtime debugging. It's very useful actually. And the next thing, we have no more grammar here now, so we put end of our grouping. These are called grouping. This grouping symbol is line. This is non-terminal. These are terminals. Then we have to define. So don't forget putting semicolon here. Then enter. Then draw it here. Easier look. Every grouping should terminate with a semicolon. It's rule. We should keep the rule. expr expression. That should be, I will use intg like this, and it has no value. This is semantic value, and $1. It means the semantic value of intg is $1. Okay, intg integers value to expression expr assign it. It means $, means groups non-term groupings variable or expression. This is first one means first elements groups rules element semantic value intg's value. Okay, then once again we should end with a semicolon, or we can put like this, easier to understand. So we can change it to something like, we can do this, say this is intg, where is this token, this is intg, right? Instead intg, we can say, we can use integer like this, we can do this, it's the same. Okay, Okay, but it's easier to understand than INTZ. The next thing is, okay, we done our grammar. Now we will define our custom famous. Now yyerr. We have to define it. Should we defined now? I will define it now. Void yyerr error constant character message. This is actually wrong. We will fix it. This cause error messages. Okay, we will fix it later. I will let you know how to fix it. So let's see. I think we made lexical files, lexical analyzer, and parser file. No, we haven't finished scanner yet. And scanner will be INTG means this is wrong. We have to INTG is defined here. These are different. This INTG and this INTG is different. Where is it? This INTG is different. This is for lexical analyzers, Bisons. This is for Flexes. We defined it. We named it. Instead of this is confusing. Then you can say int. Okay, int. Then you can say this is definition. This is rule section. We have to expand the definitions. Name like this. Name definition. We extend name. Then here we are using that famous yyl. Now it's pointer. This is pointer. It should turn into pointer. Here INTZ. This is sent as a pointer. I will tell you about this later. INTZ. What it means is where this int comes from here. See, we defined int. If it's integer, then int. Okay. ATOI YY text. Convert YY text to int. Again, we can put semicolon here, then enter. We can keep going here, and return. We specify this token. Here INTZ semicolon like this. It causes trouble because we use token prefix here. It turns like this. TKN underscore. Okay, this is important because we specified here. For example, my friend Demi Moore defined like this. Then we have to do that like this. DM. My friend Jane, like JN. If she defined like this, we have to do like this. JN. Okay. So I'll say TKN token. TKN token. I will name it TKN. Okay. So prefix, token prefix. You understand? Then I will put another characters. CHARS expands to any ASCII character name. Here I will name it YYL bar like this. Now CSTR. We are sending characters to so we can't use this way. We have to allocate memory. No, we change it to like str. size t, size, we first need to know str, len, yy, text. We first need to get then plus 1 byte more, then str cpy, string copy, then what's the next? Actually we need it later. Here target is yy lbar, then cstr, target source, what is the source? Yy text, like this. Then return tkn cstr. Okay, where this cstr comes, it comes from here. It's token. This is token type, token name, or token type, token name. This is semantic value, token's semantic value. Okay, it actually causes trouble. 지금 right now cstr has no buffer for character. We haven't defined it. It's just a pointer, so it doesn't work. We have to allocate memory, right? Var cstr equals new character size. We have to do this, right? So this is correct. Then what's next? We need a new line. We have to return new line. In this case, it's simple. Just return, because it does not have semantic text. It's just yy text 0. Means return the first character. Why we can simply do like this? Well, I will say in comment section. Or simply return. You can do this. Actually, they are the same. Then we will add another debug on. This is our new command. We will return. It doesn't have semantic value. tkn debug on. I mean, we are going to tkn debug on. This is tk debug on. This we are going to execute this one. Okay, we will turn on debug. This turns on debug. So this debug off. Then return tkn debug off. Okay. Then finally character. We are setting debug on. Then let's see, scanner. I'll save this. Scanner character. I will change it. I will change the order. Okay. Okay, the next character is any character, any other character. This means any other character. It does nothing. Just eat up. Oh, sorry. Okay, now done. This is done. And okay, now let's build. Let's compile and build. While building, I will explain details. Okay, so let's try with lexical analyzer. Right click, compile. We will have lots of error messages. first failed. If you don't have these verbose error messages, if you don't have messages the error message is cryptic, then you have to turn on. You have to turn on build. You have to turn on normal. Okay, default is minimal, so you have to turn on normal or detailed. I think normal is good enough. Then let's see. The first value low, blah blah underscore character warning use the value. Lexical analyzer. 108, 108, 1, 1, 108, 108, 108, 108, 108. Warning use the value L1. You're right. Define value parser is not used. Okay, it's no problem anyway. I put CSTR. I will just use this is just warning, right? Error. This is error message. Define variable parse3 is not used. 16, 16. Define parse3. It's okay. Why this is error message? Oh, this is not trace. Define parse trace. Okay. I will compile again. CSTR warning use the value. Build successful. Unused value. Oh, this value. What it means is it's not serious because we will fill code here. Here. C stars is the value is semantic value is defined but not used. Means we will put code here, so no problem. Let's put code cout $1 and there it's a semantic value like this. Then this warning will be gone. This warning will be gone. I will try it. Compile it. Error. This character. 109. Oh, I put twice. Okay. Then compile it. Okay, it is now built. Now we will build compile scanner, but we still have a lot to go. Scanner, we will compile scanner. Compile. Failed. We will fix. Generating next here. Premature EOF. What's premature? Let's see what's premature. Option. This. Okay, I think it's not enough. We will turn on more specific, more detailed error messages. Go to build here, detailed. Then compile again. Let's see. Build compare. I don't understand. Let me check with the command line. Sorry. Okay, I will open command line. Visual Studio. Mac Visual Studio. Tools, I will drag. Copy it here. Here. The result. What's the other program? Console Reentrant. Console Reentrant. Here. Here. TV. Win. Flex. What's this? Scanner. L. Oh my goodness. How do you say? Win compact. It gives no error messages. I'll use Bison and Flex. Hold. I actually made error here, I think. Let's check once again, 19 by 19. I think I made error intentionally. Oh, I have to remove this percent, okay? Save it. It actually gives error. I will save it, compile it. Failed. Now I will change debugging mode, message mode here. Normal. Compile again. Compile. Failed. I made another error, I guess. Let's see what's the error. Ins. Here. Debug. I don't think this is error actually. Control F7. Oh, let's take a break. After taking a break, I will be back. Hi, I am back. I found a very stupid error, so I will fix that. Right click. Here I put typo. Identity. Like this. Identity. I misspelled. Let's check. Here. Identity. I misspelled. So save it. Okay, let's build again. Compile. Succeed. Then I will make the error coding shorter. Normal. Build again. Compile. Okay, succeeded. Now we have to add the generated files, header file, right click, add existing. Say we are going to add a CPP, no, header file H, two header files. And another one is analyze H, add, we added Then we add the source files, add existing Lexer CPP and scanner CPP files. Here, now we will see in what's generated like this. Here, click. Let's see. This is the class we defined. First, we will see Lexer. We have to make argument the same. Here, first, we will see. Go down, go down, go down. yylex. Okay. This is default creation. This is wrong. This is the one we are going to use, but this is not good enough. We forgot one thing. And let's see, this is Bison scanner file created by Flex, and let's see how Bison calls it. How this is analyzer CPP generated by Bison. Let's find yylex. Okay. Here, yylex analyzer. This is calling like this. YYL value, YL log location. We have to change. We have to make identical. Lexer and the parser should be calling the same way. We have to. It's wrong. This Lexer definition, I will show you side by side. yylex scanner calls yylex. This file definition is different. We have to make the same. First, scanner, we have to enable here option reentrant. I think we forgot one thing. We have to enable this. Okay. After enabling, it will change. The scanner will be, this setting will be changed. So we have to enable this, save it, and regenerate. Lexical scanner, compile again. No, see, it's changed. How? Now it's getting similar. yylex scan like this, and analyzer here, yyS type. This is yyS type actually, and we still have missing here. One thing missing still. We still missing. This one is missing here. We will put it. So Bison location. Sorry. We have to enable it. Save it. Now generate once again. Compile. It's changed like this. This is now yyS type, yyl type. This is location. Comparing it, it becomes similar. But not yet exact. We need this. How we define this? We can't change it anymore, so we have to change this. And lexical analyzer, we have to put here. This we have to put lexical analyzer parameter. It should be parameter define parameters. It should be let me see, go up parameter define. I can't see it. PARAM. Here. This is changing scanners parameter. Let's see this. We have to make like this. I will see this. We have to generate like this. To do that, we have to add this one. This changes lexical analyzer scanner argument. save it, then we generate, compile. So let's see, this is generated one. Now it looks similar, same, not similar, same. See, yylex. This is scanner's definition header file generated by Flex. The first thing is yyS type pointer, yyS type. This is yyS type pointer. See here, yyS type. This is actually type pointer. And this is yyl type, location type. And this is scanner type. So they are identical now. So we resolved yylex calling convention. And the next thing we have to resolve is now find yyparse. yyparse. This is actually not resolving, but we are changing it. Currently, this is scanner. This is actually, we defined it like this. Analyzer here. And see scanner. This is if we define parameter scan, it applies to both scanner, analyzer, and scanner. So we want to pass our class. See, we want to pass this class, instance of this class. This class is defined like this, instance of this class to lexical analyzer. To do that, we have to define parameter. We have to, if after this, I will show you how code gets changed. After this, we enabled it, then it will be changed. How? Let's see. Right click, compile it. Failed. What's the problem? Oh, misspelled. Here, like this, misspelled. Compile it again. Failed once again. Parse PALAM. Parse. Define parse PALAM is not used. Parse PALAM. Oh, this syntax is wrong. We have to do this. Okay, we have to fix like a PALAM, parse PALAM. Okay, save it. Then compile again. You have to watch this. Okay, it's changed now. Now we can pass our parser class to our class, scanner parser driver class. It's our own class. We can now pass as a pointer. Then we defined. Then another thing we need to note is, see, global function again, yyerror. We need to have header files for yyerror. This is yyerror, but this is not correct one. Let's see why it is coming like this. Okay, we have to remove. Let's try to find yyerror here. Lexical scanner. This is wrong. Home. yyerror. Okay. Next. Match case. Next. Here, this is the one. We have to change our header file like this. I will try one more. Sorry. This one. Its syntax is something like this. It does not give us It does not give us header files. Now, function signature, I will copy it and comes here, yylex. I have to change it, something. This is wrong. This is correct, so we have to fix it like this. Extern. It returns nothing, void. And this is yyl type pointer. Then we fixed the first argument. Now second is yyScanner, yyScan t. Okay, so second parameter is fixed. This is the parser class we passed. This one. This should be C. What's that? Let me check the class name once again. C scan parser. C scanner. Parser CLS. Next. Let's go next. This is character message. Just constant character. So we have to fix this way. Okay. Then we copy it. This is also wrong. We copy it. Go down. We have to fix it. I said we should define it now. Error message. It's wrong. yyloc. We actually don't need to define this, but we just put it for later use. Scanner. You can change it here. You can change the message. Then we can put here error message code std cout message std, and then we can do this. We can fix it. Okay, save it. About the details, it is listed in Bison Flex manual. I actually read the manual several times and tried it, and I figured out. Okay, let's try. Let's compile this again. Let's build. Compile. It compiled, but we still have problems. We now have to compile C. Header files, compile. Okay, error message. Macro redefinition. We still have some errors. See, this is actually wrong. I will fix it. Here. This is wrong. We have to fix this. Using this class. Why? yylex. This is the header type. This is the correct one. So we can say copy. Copy. Then paste it here. We have to fix like this. Let's see. Save it. This is wrong. I said this is wrong. external anti-yylex type scanner. Okay, let's save it. I'll make it smaller. Now I'll compile it again. Generate. Generation is successful. Compile. Here. See, unexpected end of file, looking for unexpected end of file. If you see such message precompiled header, you should set you have to disable precompiled unused. This step is important. Okay, you should use not using precompiled header. And now let's compile it again. It will still have error messages. yyScanT undeclared identifier. See, yyScanT is undeclared. This is coming from lexical analyzer here. We have to define yyScanT. yyScanT type typdef. Why is giving us error message? yyScanT. Which line? 551 151 type def. Let's try it. Type def void yyScan yyScanT undeclared identifier. We declared it. Why is giving 151 150, not here. Here, yyScanT. Let's put it code required. Okay, put it to copy, put it code required here. I will put it here. Okay, I will tell you the reasons why now. Click build. Okay, then compile. You still have error messages. See out. Now it's trivial, right? These messages we already well know. What's the problem? These are using namespace. Using namespace space space std, because these are from standard libraries. Then compile. You can say Ctrl F7 and analyze. Compile. Void error. Class character cannot convert parameter 3 from class. Oh, I made mistake. It should be copy, and it should be pointer. Then come down. Yes, it's pointer. Save, and let's compile. And wow, we finally compiled. And now let's go scanner. Let's compile. Let's build compile scanner. Then scanner cpp compile. Say if you have unexpected end of file looking for precompiled header, never forget to not use precompiled header. Okay, you should set it precompiled header. Okay, now compile once again. String copy. See, this function is variable. Okay, I actually knew this. I intentionally made this. And because this C Visual Studio is more strict about the security vulnerability of security, it should be fixed like this, and it needs size like this. Then it should be fine like this. Now compile it. No, we have to build again. Then compile. Wow, we compiled. We finally compiled. Wow. But we haven't changed it yet. Now, let's go to our class, our wonderful class. We are making reentrant parser and lexer. So now we are working on this class. Double click it, and we are going to add a function here. The function is run parser. Here, parser like this, and std string file name. Yeah, like this. String code is squiggle, that means include string like this. But actually I don't do this because we are using Microsoft Visual Studio. We can put it stdafx here. We can put it here. Okay, save it. Then can compile it. Then comes back. What was we working? We are working this one. Then it goes. Then we put semicolon here. Here, copy, and come here, paste. Here, put here, sorry, here. From here we start another beast. Okay, so let's see. Here. Now we are adding code. We have to create YY scan T. YY scan T. We have to make a scanner variable here. We are creating entrant scanner. So all scanner, I say flex state should be preserved between yylex calls. This scanner variable is used by Flex by the Reentrant Flex scanner. Okay, so it's very important. This variable is very important. The problem is that it's not yet defined. We can define it very simple. It's just nothing much. It's just this type df void point. YY scan is just a void pointer. Okay, it's nothing much, just void point. We save it. Then here, because this is the implementation file, it comes from here. Then we have to initialize, we want to pass our class. We have to initialize it, yylex. Actually we have to include here. We include here. What should we include? We have to include this part, scanner age, generated by Flex. Scanner age. Okay. Then we have to include parser, another part, like analyzer age. Okay. This is generated by Bison. This is generated by Flex. Okay, we need these two files. And here again, yylex, what's the file? yylex, init extra. See, user defined data type. What is user defined type? What should we pass? We are going to pass this class, scanner parser class. We will use this. How? I will talk more about this later. Just this, pass this. This means this pointer to scanner parser CLS. Confusing, right? This means this pointer. This pointer. If you don't understand C++, you cannot follow with me, okay? You have to understand C++. Then scanner. We have to initialize like this. I have more to say about this. Then another thing is set. I will talk it later. Then int. No, I don't need it. Then parse. yyparse. The first element, scanner. This is scanner, scanner, scanner. And the second is the scanner, parser scanner. Scanner parser CLS. This. Okay. This. Then that's it. We are calling yyparse. Then after yyparse has returned, I will save it. int, yyparse returns integer value. So after this, we have to destroy yylex, and des destroy. We have to destroy scanner, this scanner, like this. Sorry. SCA, and then here scanner, like this. Let's see. Okay, then it's done. Then we can, no, it has no return value. We can return this actually, int. I changed it. Then I have to change it here to int, like this. Then it's done, I think. Go over. That's okay. First step is we declare a scanner T. This is compulsory. Okay. Another thing, we have to initialize this, and we pass argument. If we are not going to pass this, we can say About details, read the Bison and Flex manual. Okay. Then destroy. Then return RLT. This is our function we are defining. Then save. Then comes here. Let's compile it. Compile. Okay, we succeeded. And we are going to make it now this part. This is our function main. First, we need to include this class, this part, scanner header part, scanner header part, scanner header part. And of course we need, if we want to do something, that's okay. Then here, let's see scanner class, then we make C scanner CLS. Because we defined functions here, we are going to call this function. We are going to call it. And this function actually does the work. I mean, it creates scanner, then calls parser, then destroys. So here, and I will say SP. Okay, then SP run parser. Okay, it requires file name. I will do this for the time being. Here I will make a default file name default blank. I will fill out later anyway. Now everything seems to be done. Now build. Wow! We finally created exe application. You see this? 2 hours 15 minutes from the start of this video. I finally created exe. Let's run it. Try it. Control F5. Okay. Now debug on. Wow, it's doing something cool. Debug. Oh, this feature is very important, you know, runtime debugging. No debugging is coming out. If I want to debug again, I mean my logic, my language. I mean I'm developing language, right? Then I can debug, turn on debug again, debug on. Then it gives me about the stack and something like this. I will close it. Wow, we have come a long way. Congratulations. Let's take a break. Then I will explain you very important thing. And one thing good is that I will provide technical details about this code. Why I have this, all the details I will make technical documentations for in a one place. Just in a single document, I will code every lines. Then I will provide you. After taking a break, I will tell you something very important. Let's take a break. I will be back after 10 minutes. You can pause and have coffee. Okay, I am back. Say, we are creating a Reentrant parser. And I will show you, before I go on, I will show you one thing more about this. This is already pointer, then why it has address. Okay, I will show you one thing. And pointer itself is, if you don't send this squiggles at first, and this is, we defined it, actually Bison defines, but it declared here. This is void pointer. Then why this is it is already a pointer then squiggle because it's a pointer to pointer. This is pointer to pointer, so I have to fix like this. Save it. I will explain about this too. And let's get some big picture. Okay, so class, we created a single class here by ourselves, and this class is very simple right now, but we will flash out. Flash out. We will fill more code here. We will use this class as control point. We create here one SP, and if we create another, we can create any number of instance. Any number of instance and call it to assign it to different thread. Then two instances can run simultaneously. I am not using thread right now, but I will demonstrate it later in next video, in other videos. Then these two parsers can run simultaneously. It's cool. That Reentrant parser is really cool. See, we need to here. I need to include here. It will give us message saying std out. And here I will get a result. See, this run parser actually returns integer pointer, and this is the result of yyparse. It returns, then we catch the result. We receive the result and display here. Then a second run option runner runs. So let's run it. Let's see what happens. This is first section. Then we close it. We end this session. Then parsing ended with code 0. This one printed. Then another parser runs. Okay. So in real program, these two instances can run simultaneously using thread or whatever. That's the reason why you are using the entrance parser anyway. Another thing I would like to mention is we can access them. We can access this class, and to demonstrate that, I will add here a message. Here. In fact, I don't usually use raw C++ pointer much, but it's for demonstration purpose right now, just for demonstration or to help you understand. I will add here a member function, and Here we will deploy we will print out this message. Okay, like this. We added a function. Then we will access this class, our own class, in Flex and Lexer. Okay, and come to scan. Let's scan with analyzer first. Here, in our rule, I will add one more scanner here. Here I will add one more rule, scanner rule. Say hello. Here, return trn tkn hello. Say hello. No, I will not use this. Okay, no problem. You can use that. But we have to pass argument here. Here we are accessing. This function. How can we access in Lexer scanner? This is by Flex file like this. yyextra. This is pointer. Say hello, and it takes C string. Say hello takes a C string. It is character C string. Yeah. See? Wow. How are you? How are you doing? Simple message. Then we don't need to return actually. We don't need to return. Like this. You are saying, how are you doing? I'm scanner. How are you doing? Okay, save it. And lexical analyzer, remember yyextra. Lexical analyzer, we are saying okay, I will add here one more instance. Here. We are going to create the C string another one. Copy and paste. C string means hello. Hello. I will add it like this. Like this. Hello. Then here I will add another rule. I'll put another rule here. Hello. Then see out. What's that? Here, let's see, save it. We need to examine one thing. here, parameter, we put this one, scanner parser. We use this one here. Does it return message? No. We just like this. Then say hello. This semantic value is $1, like this. Then we have to delete $1. Okay, that's it. Then save it. Okay, I can say here one thing more. I will add one thing more. I am parser. Okay, I will not use this. So I will not use this. I changed my mind. I will show it later. Hello does not need token. Hello does not need semantic value. I will not send semantic value, just token. Okay, save it. Here I have to fix it to it does not have message. Instead it returns. Sorry. And it return tkn hello. Okay, then save it. You can do like this. See, we defined hello, HALLO here, like hello. When we access in lex, we have to put tkn as prefix because we used option like tkn, token prefix. Now save and run it. Control F5. What's the error message? I probably made a mistake. Hello, missing at the end of line. Oh, we missed closing quote here. This is lexer, yylex 112 here. I missed closing quote, and then Control F5. Say hello. What's the point? To class and structure? Say hello. Sorry. Now let's run again. Left of say hello. Oh, let's see. What's the problem? Here. Oh, we have to enable this. Okay, we have to enable this. So I ask this. Extra type means we are going to use this class's pointer. Save it. Now F5. Now we do as normally. Syntax error. Normally. Say hello. Thank you. You just accessed the scanner class. Your message, I'm scanner. How are you doing? This comes from lexical scanner. This message comes from this part. Then it returns hello message to YY scanner here. Lexical Bison parser. Then it says I am parser. So see again. So thank you. You just access the scanner CLS. Your message, I am parser. See? I am parser. We are accessing. You understand the order. Thank you. You just access scanner. We access, say, okay. The point is that, my point is that we can access our class in Lexer, in lexical analyzer code, like this, using this statement. This where it is, we just enabled. No, this is analyzer, this scanner, using extra, extra. To use it, watch carefully, to use it, sorry, we have to enable, we have to add the extra type option. This is the reason why. And how Lexer knows this class. How Lexer knows this class. Because Flex scanner knows this class, because we sent it here. When we call Lexer, this is yyinit extra. This is extra is this. This is this class. Okay? And again in yyparse, it also accesses in yyparse and Bison file. It also accesses our class. This scanner parser. Say hello. What is this scanner parser? We defined it here. We passed as a parameter. We defined here as a parameter. Scanner parser. I will show you three parts simultaneously. So this part is important. Parse parameter defines actually this, and lexical analyzer here is lex. When we define lex, we use extra type. This option gives scanner to access scanner parse our class, our defined user class. This class we defined by ourselves. And in Bison Flex, Bison file, we have to give these options. And this enables us, when we create them, when we call them, we sent this class here. This means this. This means this pointer to CS like this. This is parser. This is lexical analyzer. In lexical analyzer scanner here, it is, when we access it, we call extra here where it is extra. Okay. Then to make it more clear, I will show you another thing. It is very important actually. I will make it. I think this code is very ugly. This code looks very ugly, so I will define really ugly code, so I will make it clear and pretty. Now rule section, now user code begins here. We can define this function. This function is, I will say, copy CSTR. CSTR means C string, character pointer, target, P target, and character pointer, P source. We'll copy, okay, copy. First we need the string size T, size, P source. We now know the P source. Then what should we do? we have to dynamically create string, right? So p target here, p target new character size. Okay, we will plus 1. Then create it. Then we copy str cpy s should be p target. Then size. Then p source. Okay. Okay, we saved it. Then you can change it to shorter like this. Copy. 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 Copy is cstr. We are using this function. Here, this is target. Then this is source. Then we don't need it, right? We delete them. Okay. Like this. When character this tk and cstr returns to Bison. Where's the file go? Analyzer. Okay. Here, when it returns, it comes to character cstr. It comes here. Okay, here. See out. It have to be deleted because we dynamically allocated the memory. Here, let's see. We used yycstr. We dynamically allocated the memory, so we have to delete them. Let's see. YY scanner here. We have to delete. This is character pointer. Okay, like this. We have to delete. Now save it. It should be displayed here. Now let's run. Control F5. Sorry, I have to put it here. I can put either code section or top section, either this or what is. Okay, I have to put it here. Then actually we don't need external, right? So let's save it. Let's run it. Control F5. Enter. It sends character. Bam! Crash it. What happened? Close program. What happened? What has happened? And we know we sent in our program we sent it twice, but it crashed. It doesn't run at all. How? What happened? Let's see. Understanding this can be sometimes important. I will close the mail notification. Okay, because we will test it here. What's the problem? std cout here, std cout, and p target and here after this, okay, I will put pause here. We have to click enter here. Let's see, like this. Let's run. Should semicolon. See, watch carefully. Enter. In copy Sistra, it is copied properly. After copying text, watch. In copy Sistra, it is copied. P target is properly copied. Then after copying text means here. It is running here. Sorry, I will close it. I will fix it. It crashes because I will explain. I will tell you why here. And we can display yylex cstr. This I fixed it. It should display the text. It crashes. After copying text, it's nothing. It's nothing. It just crashes. Why? Why this happens? Why? It copied this text. Allocated, copied. Why this happens? Because this is pointer, however this is pointer too. This is pointer. We have to change it to pointer like this. We have to change this pointer to pointer. Okay, then it should be, this is already a pointer, so it should be pointer to pointer. We have to fix like this. Here, that's the problem. So we have to fix it here. You have to fix it here too. Then run it. Here, what's the problem? Cannot convert point. Okay, we have to fix it. Here. We have to fix it like this is all pointer to pointer. We have to change it to pointer. We have to change it like this. Also, we have to change this. Now let's run. See? Wow, it's working now. My point is, when you pass pointer to some other function like this and you change it, you have to use pointer to pointer, because pointer, if you do this, it gets a copy of a pointer value, a copy. But when it's a copy, not real one, so we have to use pointer to pointer. This point is very important. Okay, we will use it. We will remove it. Ctrl X and put it here. I will make it member functions like this. Copy it. Copy it. I made it as a member function, and I copy it once again here. My point is, you can define your functions, routines, everything in this class, as a member of this class. Then you can call them in your lexical scanner, and we don't need it any longer. We are not using it. We deleted it actually. Then you can say here, I tell you once again, extra. Okay, I am reminding you once again, extra. Wow, it's cool. Okay, it's cool. This YY extra means this class instance. Why? Because we sent it. We set it. So here is perfect. Now run it. I hope you understand my point. Wow, it works. Okay. So using this method, we can control lexical scanner and parser. Where is it? Parser generate file we can access like this. It could be very complex, very difficult to understand, very long. Don't worry, you don't need to do all this all the times. You don't need to do this all the times. Because at the beginning of our session, we know how to make template, right? Let's close this solution. Our project is done. Close. Then we are making a brand new one. I will make a short project. We are making brand new one. Just short. This is your new project. We are adding files. Parser, lex. You are adding new code. Lex. And adding this parser header file. No, parser implementation file. Add. And parser header file here. Parser header file. We have to change it. Of course, if we name this way, we have to change a lot of other things too. Then our main driver file, main app file application. When you create next time, you can use all these stuff. Okay, we don't need it. Remove. Delete. Then it works because all details are here. What you need is to specify here your routines, your new routine, your new logics. You can just fill out the logics, add more code. You can just use it. One thing, you have to change the settings here. I couldn't make it automatic anyway. Custom tools and apply here. All you need to do this. This is lex of Bison file. Flex. Compat. Don't forget this percent. Identity. Okay. If you don't remember the spellings, identity. For example, if you are not Americans or English speakers, native people, you may want the spellings, then look at this identity. Okay, then you can put here this is minimum, but this is not dollar, this is percent. File name cpp, then file name h. I can copy it for apply. Okay, then here also participating here, this no here, this time it is not, this is Bison identity, it should be win Bison, right? In your case, if you are not using sequin Bison, in Bison percent identity. Okay, save it. Now it's not, we haven't yet done. Compile it, succeed, compile it, succeed. Now we have to add a source code cpp hp like this, and it's not yet done. I will explain you. Add existing two header files, and save them. Let's see, parser. I think everything is ready now. Let's build, rebuild all. Oh, I have one error message. And what's this? We made error. See? You forgot one thing. We forgot one thing. Unexpected end of file while looking pre-compiled header. This is very easy to forget. So we have to right click here. Preprocessor pre-compiled header. We have to disable it. Okay, like this. Okay. Then also we have to disable pre-compiled header. Like this. Okay, now build again. It's very confusing, easy to forget. Wow, everything works. See? Right now, 3 hours. I recorded video for 3 hours. You may feel disheartened. If you have seen this video so far, you are really great. You are hardcore programmer. Before I close this session, I will show you what kind of program you will build. If you understand, or even if you don't understand the whole thing, don't worry. I will show you every details in the future videos. We will use this code as a stop code. I will take a break, then just 10 minutes or 5 minutes more or 10 minutes more, I will show you what kind of program you will develop or code, how to implement the class and functions or scripting features. I had a coffee break. I'm back, and before today's purpose objective is achieved, I demonstrated you how to register, and you may have to watch this video several times, 2, 3, 4, 5, and you have to follow. You still don't understand it completely. No, never. If you are first user, you haven't experienced much about language creation. You cannot understand all. But don't worry. I will try to explain details in future videos. Then you can watch again and follow code, and you read the manuals, Bison and Flex manuals, then you can do it. I will close it. Before I close, I will show you what kind of software you can develop, how you develop language. This is yet another language I developed from 2024 to 28. For 4 years, I have developed this language. I will show you. This is based on Windows XP. See, this is 26, 28, Silicon Dynasty International. This is programming language, scripting language I developed for scientific purpose. First of all, this language is very advanced, often. For example, this is the very basic. These are samples. Hello world. This clears the screen. Hello world is like this. Hello world of the screen. Hello world is displayed here. Execution time. Blah blah blah. Then the next code. Most people think about is how to make functions. If construct, I will show you. This explains if construct. It gets input from user, two integers. Get two integers. I will make it bigger font. It receives input from two integers, like a cin in C++ language. I can use like a cin. It's no problem. It's optional actually. Then I run it. See, it asks input data x, y. X, y means this. Okay, I will get two integer value from the user. For example, 4, 5. We can put expressions like 6, like sine, for example, 60 degrees, like this. You can even put expressions here. Okay. Then the result is, let's see here. 4 is not greater than 4. The result was 4 because it was integer. And I will try it again. 4 plus 5. Okay. We change this. It is 9. 4 is not greater than 9. Okay. The result is calculated here again. For example, 1, 2, 3, like this. This is 1, 2, 3, 4. Okay. 4 is not greater than 9. Here, that's greater than, for example, 14 plus 2. 12 is not greater than 9. No. Try quadratic equation. Yes. Real value, for example, 1 minus 5, then 6. It solves the quadratic equation. Okay. Then the result is displayed. X1, the result. Try again. Yes. Now we will go into complex domain. Like this. This is a complex. The solution of this quadratic equation will be complex number. Okay. Then complex solution is done. No. This is the power of scripting language. See? Do you want to continue? This message happens as dialog box, and it solves it asks user 3 numbers, real numbers, and solves quadratic equation. If the discriminant is greater than 0 or equal to 0, then it gives a real solution, real value solution. If not, it goes into complex domain. Do you want to continue quadratic equation? If yes, then go to 2 again. It gives go to. It moves back here again. This demonstrates scripting language for if-then structure, if structure. Then this hello, thank you, have a nice day. This message is displayed here. Another one, more advanced ones. Now I will scroll down. I cannot I don't want to make you bored. I will give you two-dimensional array. Then this solves array. Like two columns, ask input row count of m. Input row count, column count of a column. And it asks to row and column and resize elements. And it uses for loop to use random numbers, assigns random numbers to our array. Then displays the result like this. I will clear the output window. I don't need it, and I will put it here. Then let's see. Let's run it. Run. Input row count of m. This message is displayed. And for example, 2 plus 2. And column count, for example, 3. Then it assigns random numbers like this matrix here, assigns and displays them. This is displaying. This is assignment. This is displaying. Random is random number. One thing more. This is how to solve really complex scientific problems, like complex and vector. I will show you vector class. This is, you can define classes as well. For example, this includes vector YL library, included vector YL into current module. This loads vector library, and this is vector. We define vector and set the vector element like this, and displays. Vector v1 is displays, and calculates, converts it to spherical coordinate format, and displays. This uses classes like classes. This class, let's try it first. Let's run it. Run. Then the result is displayed. All this vector computation is resulted. Rectangular coordinate. Then rectangular coordinate v2, 2 vectors. Then vector is rectangular coordinate equivalent to this vector. This vector is converted to cylindrical spherical coordinate system. This operation does the code. And this demonstrates class include statement. This is class defined in here. I will show the class. It is user defined class actually. Let's see. It's here program. Here. Sample library. Vector. This is the class. This code. Let's see. This code includes, this is vector class. It is defined as a library. User can define this class by himself or herself. And this class actually includes the mathematics class too, mathematics file, and this program includes this file. This program includes, and this includes mathematical YL, like another class, mathematics YL. Include, this is mathematics YL. It defines polar coordinate class, etc. It is all user definable classes. So this language, yet another language actually support class. And another thing cool is that I will go to sample again. Here, my document. Yeah, I will show you very good, cool sample scientific eigenvalue calculation. Here. Eigenvalue, okay. This program solves eigenvalue of matrix system. This is matrix, and creates determinant, etc., 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 and does computations and so solutions and displays. And this is characteristic equation. I will close it. Then we will run it. I will clear the output and run. See, x is 0, the element of M. It means this matrix is calculated dynamically, like x value x is 0. This value becomes, this first term becomes -3. For example, this term becomes +3, like this, and this matrix is solved. Determinant is 0, and characteristic equation becomes, this matrix characteristic equation becomes like this. It is, each eigenvalues are 1, 5, 6. Another thing that nobody else, not anyone else may know, is that this language supports international language, not just English. It supports all kind of human languages. I mean, keyword can be defined. Keyword include. This is sample probable demo. This is include statement. How to use include. For example, this class can be included. It has something like this. It uses math formula class. Let's try running. I'm not sure if this library is here. Let's run. Clear. See? The area of circle of radius 1. See, area of circle of radius 1 is like this. This is using the class math formula class. This is for demo program. Math formula, it uses like this. And area of rectangle base 3 height. This is used. This is using functions, formula, class the user can define. Math formula, it defines function here. 986 includes standard library here. Let's see where it is. Nine 986. See this formula, this atom class, this program, this user program include math formula here. Math formula here, mathematics, not this one. Not here. It is here. Where it is? Yeah, silicon diners. Yeah, library. Math formula. This one. This one defines area, triangle. Pi defines formula triangle like static. Class inside class is accessed here, like this class formula. It has many more features that normal program doesn't have. Normal language program doesn't have. For example, it supports UI language can be user interface language. I mean, keyword can be redefined. I will show you as last example. keyword, let me see, not this one. Keyword include, not this one. Return. I cannot find it. This way, after learning Lex and Bison, you can make your own language. I hope you aspire and desire, you have burning desire to learn how to make programming language. Thank you for watching for long hours. If you like my video, please leave a comment, and if you have difficulties while learning this tool, learning Bison and Flex, write email or comment at your comment section below, then I will surely help you. Thank you for watching.